Time for another DraftPhysics.com, DebatePhysics.com, also video presentation. So some comments. There's no point. They won't counter-argue anything I have drawn and explain how it's wrong or incorrect or how they have some evidence. And so it's, what's the point? So I drew, well, now whatever, at least a dozen times, the simple Newton's cradle argument that they claim is a truth and I claim is absolute nonsense. That is, if I take one ball and I hit the Newton's cradle, okay, one ball flies out, just keeps going back and forth. The momentum's conserved. The kinetic energy, you could argue, is conserved, because it's all the same mass. And the trick is that I could take one and drop it against three, three mass. And somehow, if I just make all of those stick to each other, I can create 150. I can take 100 momentums in and make 150 momentums come out. So just magically I get extra, plus I'll get back 66% of the energy I started with, or 50%. So I'll get back half this, and all I have to do is add another half, and I can do the whole thing all over again. And technically their theory is that if I had a mass of 6 or 7 times this mass, that I could actually give this twice the momentum, and this would come back with all of its momentum. So I'd get it right back to where it started from. And it could just keep doing it over and over and over and over, making more and more energy, free momentum. Now, they can't debunk that, because that's what their theory says would happen. And the only debunk is, well, there's no evidence. Yes, but you haven't done the experiment to prove it. So that it happens or doesn't happen. And the fact is, it doesn't happen. Everybody knows it doesn't happen, just like everybody knows that a 5 mass going 10 is not going to win a tug of war against a 10 mass going 5. That they are, in fact, the same power, the same capacity to move matter in the universe. And they're the one they claim to have twice as much energy, right? It's not a small amount of extra energy. It's twice as much. Won't win. And I can just keep doing this. I can do the 5 times the velocity and 5 times lighter contest. And now it's supposed to be 25 times the energy. And no, it'll be a tie. It won't be 25 times. Just like I can do the recoil of the gun, tie a string to it, okay, and tie the string to the bullet, and theoretically, yeah, it's the same energy. The bullet isn't 1,000 times, doesn't have 1,000 times more power or capacity to do work or capacity to move matter or capacity to win a tug of war. It won't win. And the lever proves all this, because you can put the two things on the lever to some scale, maybe to 101 scale anyway, and prove all of this, that momentum always wins and kinetic energy is always a fable. So anyway, but they just keep doing this nonsense. So it's not, like I said, I can't do much. Crappy, useless arguments are just that, crappy, useless arguments. You have to show some evidence, and the fact that your physics has collected none, that is, it has done no elemental experiments regarding any of this kinematics. All they've done is little fake experiments with little plastic cars and their little air tracky stuff, okay, which it always seemed a little suspect to me, just in terms of observing, that you do a tiny touch on the cart and it moves, and it seems to move faster than it really should. Like if I was in space, it wouldn't move that fast. And so it's a real thing that the fact is you're pumping a bunch of energy into the air track system, and any imbalance in the cart, that is, I hit the cart and I lift up the one side of it a little bit, air is going to shoot out of that side, and I'm basically going to create a little jet engine. So there's lots of defects you could understand in this perfectly frictionless environment. It's been created by pumping a bunch of energy into the system, and that energy can unfortunately do some perverting of the experiment. And that's one thing. And the other thing is, just lying about the experiment. That is, putting blobs of clay on it and whatnot, to change the actual experiment, to force it to look like what the book says it's supposed to be. And that's the argument. But anyway, so let's just reload this tripe. You know that F T equals mv. So again, I don't even need the Ft part. F equals mv. Force equals mv. Force is actually momentum. It's mass moving a velocity. That's what force is made out of. So the force, I would argue, in gravity is a force moving the speed of light. It's real elemental, discrete bits of force, like photons. And it has a real capacity to be absorbed by a material object and cause it to have momentum, because it absorbs the energy. Just like the Earth is absorbing a huge amount of gravitational pressure from us. Our matter moves. It pushes on the matter below us. We push on the Earth's center and create a ton of heat, demonstrating the fact that there's a bunch of force stuck in the Earth going something less than the speed of light. And that's the trick. Because it's going a little slower, it means it's piling up inside the Earth. So the Earth actually contains, if I was to draw a circle in space the same size as the Earth in empty space, there would be a certain amount of force passing through there. That means a certain amount of photons, a certain amount of cell phone calls, a certain amount of radio waves, a certain amount of radiation. And the fact is, the Earth, okay, for the same sphere made out of the Earth, contains a hell of a lot more, because the matter is doing the moving, and the matter moves a lot slower than the force. And so it's collected a whole bunch of energy, effectively, force. It's dense, very dense with force. That's why it's hot. All right, so let's get back to this stupid statement. Okay, so even starting with this crap. Okay, so I've pointed out that force, weight, all these things are the same thing. There's no point in having a different word for energy, momentum, force, weight. It's all the same thing. You measure something's weight, you're measuring a pressure, you're measuring a force being applied. And the time isn't, you're only talking about in some sort of net force applied over a net time. It's still the same net force. It's not a different amount of force because you applied it quicker. Yes, it can do different things to different material objects depending on their structure. So hitting something quickly can cause things to fracture and break, and it looks different, but it's not moving more matter. Okay. You know that Ft equals mv and Fd equals 1/2 mv squared. So of course I don't know that that's true, and I don't even know what an Fd is. So that's where this whole conversation, it degrades into nothing. So what's Fd? So I know that if I have two things in space and I give something twice the velocity, I know it'll go distance 2. Okay, it's not going to go distance 4, right? So one velocity will go this far in a certain amount of time. Two velocity will go exactly twice in the same amount of time. So there's no evidence there of what you just said. Fd equals 1/2 mv squared. Well, clearly the force that the objects contain is not doing that. I could argue the force itself, photons moving at the speed of light, traveling through space, if I was to make the distance twice, then it's going to take twice the time. There's no doubt about that. And so then you're just saying that, okay, I have some contrived experiment where I'm always applying, okay, a perpendicular force, all right, to create what is contact and friction. And then I decide that, okay, now I'm going to measure the distance. So now I give something twice the velocity and it goes 4 times the distance instead of twice the distance. I could make it go 8 times the distance. I could, by just changing the thing that's absorbing the energy, make these numbers into anything. So if I use something instead of gravity, and I use some other force, okay, and some variable force, some force that wasn't constant, and some force, say, a lot slower than the speed of light, like wind, okay, then I'm going to get completely different results in terms of how much contact I'm going to create, how much friction I'm going to cause, and what I'm going to actually do to the falling time. So I'll get completely weird numbers like 2.7 and 1.3 or something like that. I'll get there'll be no connection to, okay, it's twice the height and it's going to be twice or four times or any of those integers. I'm not going to get that, because the fact is the faster you go is going to change the relationship to that wind and that pressure, and it's going to constantly change. So as you start going as fast as the wind is going, it's going to make a big difference in how much of the wind is going to be able to push you. So anyway, you can make any kind of number. So again, you can't show any factual connection between these things outside of gravity. And it's already been conceded that, gravity creates friction. It creates contact between objects that are moving on the surface of the Earth. The gravity is the thing creating the contact, creating the mechanism that allows there to be an exchange of condition. So it's just telling you how hard you're rubbing your hands together and how much energy you're taking from one to the other. All right, so obviously I do not concede that FD is a reliable universal statement regarding how force works, that it has anything to do with work or any of that, because it doesn't. It's not doing work. So again, the rolling example is a perfect example. You roll something twice as fast, and it goes four times the distance, but it's only twice as long. It's only in the gravity twice as long. And it only gives the surface twice the heat, so to speak. The surface will not collect four times the energy. And you certainly don't have any evidence that it collects four times the energy. You're just saying it does. All right, when F is the force caused by gravity. So, and again, this is just talking about gravity as a mechanism, and you have no evidence that 4 pounds dropped 1 foot is the same as 1 pound dropped 4 feet in terms of its impact. The lever says they don't equal. The lever oscillates perfectly with a 1 mass moving 4V and a 4 mass moving 1V. So again, you're just denying the experimental evidence that does exist, and claiming that somewhere you have some evidence that evidence is flawed or broken or not worth consideration or blah blah blah, paying attention to. And I'd argue that very reliable device of the balance, the gravity balance, is telling you the truth. It is telling you what equals what, and it believes momentum is the only form of energy. All right, why would it be different with other forces? Well, because all the forces are moving different speeds and could be at different amounts. So why? Of course it'll be different. Again, just the example of wind. The wind is going 30 miles an hour maybe. It's a huge difference than going the speed of light. So our tiny terrestrial motions, of a few miles an hour compared to a million miles an hour is a huge difference. But 30 to 3 is a small difference. So obviously it has a greater impact in terms of you're going to make a bigger, as you go faster, you're gaining a higher percentage of the speed of the thing pushing you. So you can understand as wind pushes you, it gets weaker and weaker and weaker because you start going almost as fast as the wind, the pusher. And obviously we're never going to go anywhere close to as fast as the force of gravity. So our acceleration will be kind of meaningless. From 10 miles to 20 miles, we're not going to change the force any because the differential is meaningless. But 10 miles to 20 miles in a 30 mile an hour wind, it's a huge difference. Okay, at 10 miles an hour, you're getting 20 miles an hour of push. At 20 miles an hour, you're only getting 10 miles an hour of push. All right, it doesn't matter whether the force is constant or not. So it's just gibberish and nonsense. So, I mean, this is just garbage. You're not going to persuade me by repeating the same mush over and over again. You have to show an experiment that actually demonstrates this crap, and it has to be some sort of credible experiment. Car crash is something big, bold, that is just undeniably truth. Not Matchbox cars with a bunch of fucking pennies piled on top of them. No, I don't want to report it. I just want to get rid of it. I'll just remove it for now. But yeah, look, I'm just saying, these comments, I have no reason to sit there and just keep arguing the same crap. You can't come up with an answer that's actually pointed at the points I've made. So again, if you're not going to address the actual points made in the video, there's no point in your commenting, because I'm not interested. I'm not interested in redundantly answering the same canards over and over again. Alright. I've been subscribed to your minimum channel before. I had no clue that you had this other channel. Well, you weren't paying much attention, because I do mention it now and then. But whatever, who cares? Okay, now you have a clue. Okay, so this Stephen Hill. One of the craziest claims from mainstream science, which you have mentioned, is the Earth's core is slowly cooling to a solid like Mars. Well, I don't know if they claim that. I mean, it would be ridiculous if that's what they're claiming. And Mars isn't solid. So, physics doesn't say Mars is solid. It has a molten core. I mean, it's half the size of the Earth. I mean, it really is a small thing compared to the Earth. And so, obviously, it generates, and it's made out of lighter materials, too. So, because it was further out in the solar system, the further out you go, right, the lighter the materials that were swirling in the crap that made the solar system. So you can understand, the closer you were to the sun, the heavier pieces would still be close to the sun, and the lighter pieces would be much further from the sun. So you can understand that the density of a planet would be dictated by how close it is also. So yes, Mars is smaller and less dense. Okay. Slowly close. But Mars is still big enough to create a lot of heat, and so its core is quite molten. Completely completely obvious gravity creates heat. Yes. It's obvious that there's no other way to understand this mechanism of gravity. So maybe this is just worth going over again and just say, look, it didn't occur to me until recently that, this is such a, I don't know why this argument didn't occur to anybody else. It just seems to me so obvious, and yet somehow everyone missed it. People who this is their expertise, and it missed it. I mean, it seems, you just can't deny the simple truth that every piece of crap, okay, that's ever hit the Earth clearly created heat. So, I mean, the stuff flying in, all the craters on the moon kind of stuff. So the Earth has been hit by a ton of material, jostling it and heating it. And then on top of that, you have all these little subatomic particles, cosmic rays, all kinds of different stuff like that are also shooting in crap. And then you have the radiation from the sun, but, that's a minor one by comparison. But anyway, and then you have the simple fact that every single thing sitting on the Earth is still applying an inward pressure. It's still moving with momentum into the Earth. So the simple argument is I could duplicate your weight, okay, in gravity by merely moving you in a horizontal direction. So I could take you in space, and I could put a scale this way, and I could move you at a velocity, and you would hit the scale and compress it the same as your weight. And that motion is about 1 mile an hour. So at 1 mile per hour is what you have that momentum into the Earth constantly. So you're constantly doing that. And if the Earth was made out of sand, like, its chemistry was all broken, your higher density would mean that you would sink, okay, because of that extra pressure. Because heavy things apply more pressure. So they're going to end up, through buoyancy, sinking into the Earth. So that motion is always going into the Earth, and from all around. So it's a huge and insane amount of pressure. You can't even imagine 4,000 miles of matter on top of your head. So if you were in the center of the Earth, you could just imagine insane crushing pressures being created. In the sense of just all of this matter moving, trying to get through. And it really is trying to get through, though. It's trying to go to the other side. So it is being radiated out. So the very idea that they have some idea that all of this matter that's under very high pressure, that is, it's very compressed, so it's not made of helium, so to speak. There's not a whole bunch of pockets of helium gas or something. Very dense, okay, and the deeper you go, obviously the density gets higher and higher because of all this pressure pushing everything together. And what would insulate that heat from getting to the surface? There's no insulator anywhere. There's no vacuum jar that inside the Earth, a little vacuum jar that helps slow this process down. And it's all radiant energy, little photons and all kinds of little different kinds of bits of electron force, you could argue. And it eventually radiates out of the Earth. And so the Earth is at equilibrium. Okay, it's had billions of years to acquire its equilibrium, and it's at equilibrium. It's not getting bigger and bigger. It's not getting hotter and hotter. I mean, it's getting bigger and bigger a little tiny bit, but I just mean it's really not getting any different than it was 100 million years ago in terms of its basic structure. All right, and so obviously the thermal equilibrium has to be maintained by some mechanism that keeps fueling the fire, so to speak, keeps it hot, because it would just radiate the heat. Right? If the heat was originally created billions of years ago, it would have radiated out of the Earth a long time ago. So it's just sort of ridiculous to say that you could, start a fire in the center of the Earth and it wouldn't be able to get out of the Earth. Of course it would. Obviously it'd get out being a lot colder than the fire, though, because it would have to heat a ton of mass to do it. So you just go from 0 Kelvin to, 0.001 Kelvin in terms of the average temperature because of the density of the mass. But anyway, it's clearly this is why the sun's on fire, is because the sun is gigantic, huge giant object with a ton of little bits moving that 1 mile an hour. It's a little more than a 1 mile an hour for the sun. It's 80 times 1 mile an hour, so it's 80 miles an hour. Moving towards the center of the sun. And so the whole thing is hot enough that the heat from the inside does get to the surface and does cause everything to glow. So the sun is glowing because it's just a lot hotter than the Earth is, and it's a lot bigger. It's hotter for a much larger density of the sun is hot than the density of the Earth. But anyway, hot enough to glow. And that's just the difference. And so this whole bent space theory doesn't make any sense, because clearly all of this pressure is being created by gravity alone. That's the cause of all this heat. And clearly there's no explanation for how heat bends space-time. None whatsoever. So how does the heat create whatever bent space-time is? So obviously it doesn't make any sense. But it makes perfect sense to say the heat from one object pushes on other objects and heats them. And their heat radiates and pushes on something else. And so the matter is just constantly pushed into each other by this fact that every time you have a material object, it collects the force in a higher density that's moving slower. So it always creates a shadow. It always creates less energy coming out than went in at this exact moment in time. At this exact moment in time, if there's an Earth here, the force coming from this side hits the pen. The force coming from this side doesn't hit the pen. And that's why the matter moves into the matter. Okay, simple enough explanation. It's clearly a version of Fadio and Lesage gravity, in the sense that the particle gravity works. It does, in fact, create the phenomena. Then all you have to explain is how there's no drag. But it clearly is what's happening to the Earth and all the other material things in space. They're clearly hot. All right. And the heat is being created by gravity, and you have to explain how the heat gets converted into bent space, because any other explanation, you have to say that, well, instead of dying a heat death, the universe can't possibly run out of heat, because every time there's a gravitational body, it's making heat for free. All right. And if the heat isn't repressurizing the other planets, then you have a heat cycle that would be out of control. Somewhere something has to absorb the heat coming out, and it has to push it going back in again, or you don't have conservation. You would have more heat in the universe. So the sun keeps spewing energy And you'd have to explain, well, I don't ever have to use that energy. And it can just keep making more and more energy, light, in the universe. And the universe will just get lighter and lighter and lighter and brighter and brighter and brighter. And there's no evidence that's happening. So obviously all of that heat is being converted right back into creating dense objects in space, forcing matter to consolidate. So heat in the outside universe compresses, and the heat inside of stuff eventually does work its way out of the object and re-radiates into the universe, and creates more pressure. So it's just a heat cycle. And as I said in the previous video, it's all heat. Okay, all motion is heat. It's just that when it's in one direction, okay, when it's going one direction, it's really easy to use. And when it's going in lots of directions, it's really hard to capture and use. And that's the simple explanation. Energy is much easier. Laser beams can cut metal. Lights can't. You could take the same wattage, the same power, and the consolidated version can cut through stuff, and the unconsolidated can't. I can have a river just hitting the ground, and it's not doing much eroding. But if I take the same pressure, the same gravitational pressure, and I concentrate that thing by turning a nozzle and making it spray in one place, then I can do a lot of eroding. So the fact that you can do more damage, again, to surfaces and substances based on how quickly you cause them to change shouldn't be a big surprise. I want to break glass, all I have to do is hit it with a little bit of extra heat in one place and it breaks. If I take 100 times that heat and spread it over the whole surface, it won't break. Obviously it matters on how you apply energy, but it shouldn't fool a smart person that it's not more energy. It's just that you've applied it. You've tricked the surface. You've broken it. It's that simple. You've broken the rules of application, and by breaking the rules, you've caused the matter to do something bizarre. Popping the balloon. You can gracefully let the air out, or you can pop the balloon. Are you saying that one takes more energy than the other? It doesn't. It just matters on how you let the gas out of the balloon. All right. So I think that's enough of that. We'll get back to the other comment. So, all right. Should be back. So this guy says, Glenn Caldwell, thanks for your work. I appreciate your arguments. I was hoping to send you some questions at some point, so that's good. At this stage, I'm just starting to learn the subject. Okay, so I can save you a ton of time. Okay, because yes, if you try to learn the subject as physics wishes to teach it and explain it, it's going to get so wooey and so crazy, you'll never follow along. You'll never keep any kind of rational mental model in your head. Okay, because it's just all nonsense. It's crazy, entanglements, all kinds of silly crap. The universe is just really simple. So the whole idea is that there's stuff called force. Probably should be able to see some of that. Okay, little bits of discrete energy. And the force can be at a frequency, okay, which we call a photon, right? So if there's a distance between little force bits hitting something, that's a frequency. We can detect it, and we can call it something like a photon. But that's all this stuff is. It's all just stuff going in directions, okay? So little pieces of this force stuff moving the speed of force. Now they say the speed of light, but it's the speed of force. And that isn't showing up very well. But yeah, so we'll just use the other pen. Anyway, and all that's happening is there's things called matter. So there's just electrons and protons now. I'm not going to explain the difference between the two forces interacting with the two kinds of matter, because it's really not necessary to make the simple point that if this is what you have to understand, is the force is moving the speed of light. The matter doesn't innately do anything. It has no motion. It has no mechanism to move. and the force has to move it. And so if a force bit hits it, it sticks to the matter. It just adds to the matter's mass, creates a new mv. Okay, this now has a mass, a total mass, and a velocity. And the fact is that if the momentum of each little bit was 1, you could understand that, well, now that it's spread it over this entire object here, okay, that it's going to be some lesser velocity, okay, to account for the fact that it's a much greater mass. And that as long as it keeps going in this direction, you add more, like you keep adding more bits one way. So you add 5 this way, and you only add 2 this way. 3 of them are going to stick, okay, and so you keep adding. And the only change you can make is that if a force bit happens in the opposite direction to the motion, then the force bit reflects. It doesn't stick, it bounces off and moves in the opposite direction, and the thing loses one of its force bits. So if it already has momentum moving in a direction, force bits hits it, it loses one of its pushers, and it reflects this one. So it's essentially the 2 force bits hitting each other and reflecting. So that's the simple idea, is that force can hit force and then just reflect, okay, or force can hit and stick. And those are the only 2 things that happen really, are reflection or an absorption. So that's all you have: absorb, reflect. And the absorption is always just temporary, you could argue, right? Because you absorb it, you move, you're hitting more stuff, so inevitably you're going to reflect that little bit of force, so you're going to move a little bit of distance and then stop. That's what's going to happen to you. You can't really evade that basic function, but that's the elemental universe. So there's force that has all the energy, and it just jostles matter around. And one of the facts is in that jostling process, just because of the nature of the mechanism, the little bits of force will tend to attract each other. But because of charge, that doesn't happen. So you really can't do it without the charge explanation entirely. But the point is that you can see it in the big universe, that's the tendency, that the clumps of matter will be affected by absorbing force, and when they absorb force, that is, the force sticks to them, over here doesn't get hit with as much force. So if this force is hitting something and it's absorbing it by moving, that means it's obviously got hit with more this way than that way, so it's moving this way, then there can't possibly be any force hitting over here, because the force is being used to make motion over here. And that's all there is. There's just densities of force created by motion in the universe. So when a big piece of mass is moving, it means it absorbed a bunch of force in that direction, and whatever's in front of it isn't going to be feeling that force, because it hasn't gotten to it when it should have. It's way behind. Okay. Obviously. It's just an obvious fact, right? I mean, look, there's force coming. It's pushing this object. This object now has it, but it's moving much slower than the speed of light. So you can understand that it's going much slower than the speed of light. That means the stuff hitting this other side is missing the stuff that should have arrived here. It would have gotten here. The force would have gotten here if it wasn't pushing this matter. It would have been here, and it would have hit this object and equaled balanced its condition. But it can't balance the condition because it didn't get there in time. So this moves towards it because obviously, there's no counter force. So it has to get moved in that direction towards it. And that's the nature of the basic kinematics. That's what runs the universe. And so it's all just about mass and velocity. And the force does have mass. So this notion that photons don't have mass and are sparkly, magical, whatever things is nonsense. Physics is about physical objects. The physical objects all have take up physical space, and they have a physical density. It's really made out of real physical things. You could duplicate it synthetically, and make the universe. If you could make something that has a little engine, you could make little force bits. And, if you could make little rockets, tiny little rockets, and have them stick to other things that don't have any rocket and blah blah blah. You can synthesize this whole thing, And I've done that. I've created a simulation that duplicates charge perfectly, and that will grow, okay, into a simulation of everything, because it can, because it's right. So if you get this elemental part right, then every time they say something wacky, you just say, no, I'm going to sit there and figure out where the little bits are and how the little bits are moving, because that's the explanation. There's only one universe. It's the universe where electrons and protons are pushed by force. That's the only real universe. And everything else is just a complication of a huge amount of density of that universe. And so we're just seeing patterns. We are just patterns in that universe. Everything that happens there first. All right. Probably enough of a start. But I've covered all the basic subjects on the website. They're all listed on the Draft Physics website, and the specific arguments to some of the really silly stuff like the double slit and kinetic energy are on Debate Physics. And so instead of spending 4 years to understand physics, you can spend 4 hours and have a better understanding, because what they claim to be true isn't true. What they claim to be a reasonable interpretation of an experimental result is nonsense. And on top of that, they haven't done any experiments. They really haven't done any. They do these abstract, bizarre ones, gravitational waves or some other nonsense, made out of a machine that you can't, it's got 700,000 different components and parts, and you have to trust them about what each one of those parts actually does. And they can't even explain how a beam splitter works, frankly, accurately. And so the physics is garbage. It's just a religion. So you have to just say you're probably not going to learn anything from conventional physics, because it is such a religion. It's lost all connection to demonstrating real functions. All right. Yeah, so. All right, back. All right, so this Andrew McIntosh, I know I've told you, if you're not going to deal with my arguments, then we're just not going to have any more. I'm going to block you, okay? So this is it. You provide evidence or just fuck off, because this is just bullshit. We've been over this and over this and over this. I showed you the perpetual motion machine. Explain how the perpetual motion machine won't happen based on your theory. So I'll redraw it after I read this garbage comment, and it's the last chance for you. Okay, I'm just not going to play this moronic game of just keep making the same shitty arguments over and over again. And they're shitty arguments. I've already explained them. Fuck you. We're done. All right. So he says counter argument. It's not going to be a counter argument. There's nothing. You're going to add zero value. I've shown the 2 experiments. I've shown the fact that in one case it's got clay smeared all over the carts. In the other case, the carts are pristine clean. Okay, and in the second case, momentum is perfectly conserved, and in the other case, momentum is completely destroyed and made a joke out of. And the simple truth is which experiment do you trust? Professor Lewin's collision, where the carts were supposed to stick with Velcro, but they bounced. You say it comes out your way because the heavy cart, which is twice as heavy, came out with less than half the initial velocity. Exactly, right. Yeah, no extra velocity, no extra momentum. It came out with less than, because the other cart still has a tiny bit of energy left. Well, this also comes out that way in conventional science, because notice how both carts move in the same direction. That doesn't matter. The point is you lost kinetic energy. You lost a gigantic amount of kinetic energy. You perfectly conserved the momentum, but you lost a gigantic amount of kinetic energy. And that's all I need to demonstrate. So all I have to say is, where do you say the kinetic energy went? And if the kinetic energy actually went into the cart, then you were making free momentum again. So I'm just arguing again. You can't make free momentum. It's a ludicrous proposition. Whether the cart goes in the same direction or it goes in the opposite direction doesn't make a goddamn bit of difference. It's still free momentum in a direction. And free momentum in a direction is exploitable. Okay. Given the timings and assuming the flags and the carts are blah, blah, blah. Yeah, I'm just totally uninterested in this nonsense. Same direction. Look, the simple fact is you've lost, whatever, 50% of the kinetic energy. Truth, fact. All right. Perfectly elastic. I'm just not going to play all this, so I'll read the last sentence. The specific scenario of Professor Lewin is clearly a partially elastic collision. So it just, everything's supposed to be partially this, partially that. As I have over and over pointed out, none of these collisions need springs. They're all supposed to work without springs. Metal on metal works just fine. You can see air tracks, where they just demonstrate and they just let the two carts hit each other and it works perfectly. The energy goes in, one cart stops perfectly, the other cart goes. So there's absolutely no reason to have springs in any of these experiments, and they're only there to screw up the results, to make it to make a mess out of the experiment. All right. And now each scenario, different equations are used to predict the velocities after the... Again, you want to pretend that your physics says you have to use different equations. My argument is if I always use momentum, I'll always get a right answer because momentum never fails. You have to conserve the momentum. It's always going to be conserved. It's always giving you the answer of any transfer of energy is going to be in momentum. A 16-pound ball going 8 miles an hour will give pins the same momentum as an 8-pound ball going 16 miles an hour. And there'll be no evidence of kinetic energy. Kinetic energy is irrelevant. The only thing you're going to transfer is the fucking momentum. I've made this argument over and over again. You have no experimental evidence demonstrating kinetic energy ever being collected, ever being transferred from one object of a certain mass to another object of a different mass. You've never been able to convert the kinetic energy, ever. Okay, you have no experimental evidence. All right, you wrongly assume that for this specific case, the heavy mass cart should come out with 2/3 the initial velocity. That's your prediction. That's your prediction. How am I wrongly? So that's this. You're so full of shit. You wrongly assume that for this specific case, the heavy mass cart should come out with 2/3 the initial. That's your theory says, and it didn't happen. But that would only be true if there were a perfectly elastic collision, which there isn't. So there's absolutely no evidence of anything close to it. So how imperfect the elasticity is doesn't really get to the point that there was no evidence of it. It was nowhere near 2/3, and it was exactly as would be predicted, less than 1/2. So again, just more canards. So you're just such a liar. So I'll give you one more chance, and that's it. But again, you're just ignoring the argument, and the argument is decisive. You're cooked. You're finished. You're done. Because clearly this would have been exploited if it happens. So they're silly, preposterous, nonsense theory is. All right. So I take a mass. Let's just say that's an 8 mass, and that's a 1 mass. Okay, and I put 100 momentum in terms of I create a velocity of the pendulum that hits the much heavier object, and it's actually going to give it motion, and the motion will be 200 momentum, close to it. Theoretically, I could say 195, but let's just say okay, it's 200 in a perfect environment, and so. And then I get 100 back again. So my pendulum goes all the way back up to where it started. All right, so I have completely restored the energy I started with, which doesn't make any sense at all, right? And I've made 200 momentums going this way. And as I pointed out, I could have just a little gravity feeder, just have a bunch of balls on a slope. Have the pendulum hit them out, boom, 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 boom. And I have a perpetual motion machine because every single time I get back all the energy I used. So I get 100 back each time. I cause 200 to go this way each time. Free energy. So you explain how your theory has some hope of preventing that from being a buildable machine. Where theoretically is it impossible to build that machine? Explain it to me. Or at least a machine that, let's just say, will create 10 times the momentum going this way. So I'll have, let's say, 5 objects moving with, 1,000 total momentum. And I started with just one object with 100 momentum. How is it not going to happen? How does your device not actually create that? Just like your silly gun shooting 2,000 joules one direction and 2 joules the other direction. How is that consistent with Newton's third law? It's completely inconsistent. And how the fuck did the gun do it? How did the gun figure out to give the bullet 1,000 times the energy? I mean, it's just silly. All right. Yeah, so, deal with this and explain how you can, in some way, explain how your theory has a prohibition against this happening. How does your theory of physics prevent this machine from being made? You pile of scum. Okay, so, all right, so till the next time, and such, and so forth and whatnot. That's enough of a video. And so it really is. We really probably are done with drafting parts. The draft physics part is probably over. And it's really just going to be reiterating these simple arguments about gravity creating heat, kinetic energy being a nonsense fable for which there is zero evidence. I mean, it fails every test. Lever, ballistic pendulum, tug of war, fails every single test. Bowling ball, doesn't matter which way you test it, it always fails. It's just a silly fable. Then you got the double slit experiment, where they completely fake everything by pretending there's waves coming out of surfaces that are so close together they couldn't create any fringe pattern at all. And clearly the math is about the distance between the surfaces. The distance between the surfaces is creating the phenomenon, and that's clearly just an optics statement. It's basically just saying you have 2 point sources. The closer I put them, the less likely you can create a wavelength of difference between them, and the further apart I put them, the more likely it is you can make a wavelength of difference between them. So the more fringes you'll have, the further away the surfaces are, and that simple clue explains the whole thing. All right. And then you have my charge simulation that explains perfectly why there's attraction and repulsion in charge, why electrons repel each other, why protons repel each other, and why electrons and protons are attracted to each other. The absence of repulsion is really what that is. It's a push-averse, for fuck's sake. Anyway, so yeah, those 4 arguments is probably enough. And that proves the case. Physics is all nonsense. 80% of it, it's all just made up fables, false axioms. They never even repeated the Eddington's experiment from space. This beautiful experiment where you watch the image of an object, you watch it mutate and perverse and distort because of this, gravity bending the light. And in space you have 400 times, 400, not 4, not 40, 400 times more pixels to look at. It's like your computer screen being 400 times bigger. I mean, it's gigantic, a ton of information, added information, doing it from space. Takes 5 minutes, and you don't need an eclipse. And they haven't done the experiment from space. They could actually just make a video, and they could just play the video and show you a star going in and then going out. They could show you a star going down and then popping back up again. They could show you that if their theory was true. And they don't show it because it doesn't happen. They have tried it and it didn't work. And that's the simple conclusion. They can't find this magic when they actually go looking for it. All right. In the context of, this is the simple argument. The photons are the smallest thing in the universe, frankly. It's moving it's force. It's moving the speed of light. And there's no evidence you can bend a force with a force. There's no evidence I can bang photons into photons and bend them. I can't bang photons into gravitons and bend them. I can't shoot photons into magnetic fields and bend the magnetic field. There's no way that this crap happens, that gravity bends forces. Forces are bent by interacting with little bits of matter and being scattered. That's what bends photons. All right. So till the next time, and such and so forth and whatnot. hate this plant. Just, you know, you people. It's just amazing. It's amazing how the density of dishonesty. And I just had no idea that so much of the human race was scummy liar. So that's something else I learned by doing physics, is humans are scummy liars. Thank you, science, for showing me that. That scientists suck. They're lying, dishonest scum.